What we're going to do right now is work through our most recent test, our Chapter 3A test, which we took on the 18th, right before Thanksgiving. Have your test out. You might want some clean notebook paper out, have your calculator out, and work through with me. You might want to watch the video first and then go back and watch it and work with me. And then your goal is to be able to work through the problems by yourself. So then perhaps you'd like to write just the questions out separately on a sheet of paper and work them out until you can do them independently without peeking at your notes, okay? That's how you get better at doing math, okay? All right, so let's go through number one. It says that we're going to solve for x. So let me scroll this a little bit. So to solve for x, that means we want to get x by itself. So, and make sure my marker's ready. Okay, there we are. So this is a case where we have only one variable term. And the reminder here is that we're going to use the square root method when you only have one x in the problem. So first, I need to isolate my square term. So I isolate the square term by dividing in this case. Sometimes we have to add or subtract first, but not in this case. Those 2's cancel. I'm left with x plus 4 squared equals 9. The next step is I have to take the square root of both sides because I want to get rid of that radical, that square term right there. So I want to take the square root because that's going to undo the squaring. It's the inverse operation. Now I've run out of space, so I'm going to work over here. When I take the square root of x squared, x plus 4 squared, all I'm left with is x plus 4, and I can drop those parentheses, equals, now this is important, plus or minus 3. Now remember, because this is a quadratic equation, the degree is 2, that means I have 2 solutions, so I have to split this up. I leave the left side the same, it's x plus 4 equals a positive 3, or x plus 4 equals a negative 3. So I solve this. I'm going to subtract 4 from both sides. I get x equals negative 1. I subtract 4 from both sides here. I get x equals negative 7. And here's my answer, negative 7 and negative 1. Excellent. So now number 2. Same thing. I have only one variable term. It's this one right here. I need to isolate it. How do I isolate it? In this case, I have to undo this addition, so I'm going to subtract 10 from both sides. I get x squared equals 16. Wow, this is so nice. We have perfect squares. So I'm going to take the square root of both sides so that I can get rid of that square term right there. That leaves me with x equals, remember when we take the square root of a number, we always have that plus or minus. X equals plus or minus 4. Easy peasy lemon squeezy. All right, number 3. It says for any quadratic equation of b squared minus 4ac equals 0, then what is true? Now remember, we had 3 different scenarios. B squared minus 4ac could equal a number that is going to be greater than 0, which means it's positive. It can be less than 0, which means it would be a negative number, or it can be exactly equal to 0. And when it equals exactly 0, that means there's one real solution. Okay, we've had a poster on the wall with that. You had a handout on that. You just have to memorize that fact. That was pure memorization. All right, so now let's go back up here to number 4. It says solve for x. So this has 2 terms. It's got a square term and a linear term. That means I'm not using the square root method here. That means that I have to use another method like quadratic formula. I could use the x method. I prefer to use the x method if I can. So first let me check and see if it would even work. So I'm checking to see if there are any numbers that multiply to make 13 and add to make 8. Unfortunately not, because the only numbers that multiply to make 13 are 1 and 13. And so the x method won't work, so I have to use the quadratic formula, which is up here. So a equals 1, b equals 8, and c equals 13. Remember, a, b, and c are the number, well, a and b are the coefficients of the variable terms, and c is the constant. So now I'm going to plug all my information into the quadratic formula. And so x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. And all of that is over 2 times a. So let me erase this. I have a little more room to work. So when I simplify this, I end up, now remember, the way I explained to you guys was to do the part under the radicals separately. So simplify that separately, and you end up getting 64 minus 52, which is 12 over 2. And then when you simplify that, you get negative 8 over 2 plus or minus the square root of 12 over 2. Now, the square root of 12 over 2 can break down, and negative 8 over 2 also breaks down. This would be negative 4 plus or minus. The square root of 12 can break down into the square root of 4 times the square root of 3, which gives us 2 square roots of 3 over 2, and the 2's cancel, so it's just negative 4 plus or minus the square root of 3. So it's this answer right here. All right, A. Number 5, which of the following is a quadratic equation? As you heard me say at the beginning of this, quadratic equation means that the highest degree on x is 2. So which one of these problems has the highest degree? Well, it's not this one because this is 4. It's not this one because that's understood to be 1. That's not even a number. It's got to be C, all right? Solve for x. All right, in order to solve for x, we need to make sure that it's set equal to 0. And then, by the way, we always want to pull out our GCF if possible. And I'm thinking there's going to be a GCF here. So to make this equal 0, I need to subtract 51 from both sides because I want the 0 to be on the right-hand side. So I subtract numbers from numbers, so I line the 51 up with the 49, and that leaves me with 5x squared plus 5x minus 100. Now, hopefully you recognize that 5, 5, and 100 are all divisible by 5. So I'm going to come back here and divide by 5, divide by 5, divide by 5. And even this term, that's fine. And I'm going to rewrite it over here. So that leaves me with 5 times, and I still need to include the 5 on the outside when I pull out my GCF, x squared plus x minus 20, and all of that equals 0. And, ooh, I'm pretty sure that I can use the x method on this one. I'm looking for 2 numbers that multiply to make 20, that add to make 1, and actually that's a negative 20. So that would be 5 and 4. And since the 20 is negative, one of these 2 numbers has to be negative. And since this one is positive down here, I'm going to make the 4 negative because 5 minus 4 is positive 1. So that means that this can factor into x plus 5 times x minus 4. Now, what a lot of people were doing is they were using these 2 numbers, the 5 and the negative 4, as their solutions, but you can't do that. Remember, in order to solve it, you've got to set each factor equal to 0. That's the zero product property. And then solve for 4. You're always getting x by itself when you're solving. So I need a little more space. I'm going to scroll here. I'm going to subtract 5 from both sides. X equals negative 5. Add 4 to both sides here. So x equals 4. So this was one a lot of people did all the right work, but then they didn't do enough work, and they stopped and got the wrong answer because of the signs. Next question, solve for x, all right? So always check for GCF. There's no GCF here. I always like to check and see if I can use the x method. So there are numbers that multiply to make 6 and add to make 5. Sure are. My only choices are 1 and 6, 2 and 3. Look, 2 and 3 make 5. So this is a nice one. So all I have to do is write x minus 2, x plus 2 times x plus 3 equals 0. But remember, we're solving just like the last problem. I have to say x plus 2 equals 0, or x plus 3 equals 0, and solve for x. Once again, so many people, they did all the right stuff. They just stopped too soon and got the wrong answer. So I know that you're going to make sure you do it correctly the next time. Number 8. What are the factors? Okay, notice this one doesn't equal 0. It doesn't say solved. It just asks me for the factors. And so, once again, I always check for my GCF. The biggest number that divides into 12, 2, and 2 is 2. All right. Now, 2 is one of the factors, so make sure you continue to use that. So I'm going to end up with 2 times 6x squared minus x minus 1. So now I need to take that, I need to factor it. And so I've got 6x squared minus x minus 1. So in order to factor this, I have to multiply the first times last. And so when I multiply first times last, I get 6x squared. Now this is a case where I'm going to have to use the x box method because I have a term in front of the x squared. And it's bigger than 1. So I'm going to go ahead and make my x, and then the middle term is what goes on the bottom. And so I'm looking for numbers that multiply to make 6. But or negative 6x squared, I should say, but add or subtract to make negative 1. All right? And so those options would be 3x and 2x, and I have to figure out what sign to use. And so since this 1 is negative, I need the 3 to be negative. Oops. So that 3 is negative. So, all right. So now that tells me what goes in my box. So this is one of the longer problems. So I have to squeeze that in down here. Actually, I'm going to squeeze it in over here. Okay? So I'm just going to make my box right here. And so the first term goes in the top left, 6x squared. The last term goes here. And then the two numbers I got in my x go here and here. And at this point, we factor out our GCF this way and that way. So the GCF here would just be 1. My GCF here would be 3x. My GCF going up would be 2x. And my GCF here, because this first term is negative, I'm going to pull out a negative 1. And so my factors are the numbers I get on the outside. I still have my 2, and then I have 3x plus 1 and 2x minus 1. So with choice, there's only one choice that's got a 2. And now really, if you had your thinking cap on, once you pulled this 2 out, you could have stopped right there and seen that the answer had to be C. All right, let's go up to do number 9. What are the factors of 16x squared minus 9? Well, this is a case of difference of squares. And with the difference of squares, 16x squared is the perfect square, and 9 is a perfect square. Don't worry about that negative sign. That's where the term difference comes from. So what we're going to do is take the square roots of each of those numbers. That's what goes in my parentheses. I love these because they are so quick and easy as long as you recognize them. That's a 3 and a 3 because the square root of 9 is a 3, and then it says plus or minus. And it says, what are the factors? That's all we had to do. So it was C. Number 10, what value for C would make this equation a perfect square trinomial? All we have to do is, this is B, you take half of B and then square that answer. And so since B equals 6, it's 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. That's all you had to do for that. Number 11, the area of a rectangle. Oops, it says the rectangle below. All right, there was no picture there, but you could draw it. And we know the area is x squared plus 8x plus 7. And so we want to figure out what were the dimensions, what do the length and width have to be. So really, we're just factoring. And so we even gave you a hint, factoring. So if you factor 7 goes on top, 8 on the bottom. What numbers multiply to make 7 and add to make 8? 1 and 7. And so those are my factors. And so that means it's x plus 1 times x plus 7. And that's all you had to do. And so that choice would be D. You're done. Number 12, it says, what are the zeros represented by this function? If it says what are the zeros, that also means factor. And zeros are also like solutions. And so this is a case where we would actually need to solve it. Even though it's not set equal to 0, that's still how we find the zeros. So a is greater than 1, so I'm going to multiply first times last. So 2x squared times negative 3 is negative 6x squared. So that's what goes on top of the box here. So, or the x, so negative 6x squared, and we have a 1x on the bottom. And we've seen this pair, factor pair over and over again on this problem, on this test. So we've been using 6 and 1 a lot. So that's going to be 3x and 2x, and this time the 2 will be negative. That tells me what goes in my box. So please make sure you're paying close attention when you're watching this video, so that when you sit down to practice, you have some good notes, all right? So then the 3x and the negative 2x go here. I'm going to pull out my GCFs. My GCF here is negative 1. My GCF here is just the x. My GCF here is 2x. And my GCF here is 3. It's positive 3 because this 3 here is positive. If this 3 was negative, then it would have been a negative 3. All right? So now I can figure out what my factors are. My factors are 2x plus 3 and x minus 1. So we're going to have to set this equal to 0 in this case. So then I can come back and say, well, 2x plus 3 equals 0. X minus 1 equals 0. I'm going to subtract 3 from both sides. I get 2x equals negative 3. Divide both sides by 2. X equals negative 3 over 2. Here, I'm going to add 1 to both sides. X equals 1. And let's see. Looks like the answer is A, because it has the same numbers that we got. All right? Almost done here. Last page. Number 13. Which of the following is a factor? All it's asking us to do is factor. We check and see, since A is equal to 1, I definitely want to do the x method if possible. So negative 15 on top, 2 on the bottom. The numbers that multiply to make 15 are 1 and 15, 3 and 5. I like 3 and 5. One of these has to be negative. Since the 15 is negative, I'm going to make the 3 negative so that when I add 5, I get a positive 2. So my answer is x minus 3 times x plus 5. And one of these is listed over here, and it looks like it's that one. All right. Number 14, factor completely. Always check for your GCF. The GCF is 2. So that gives me 2 times x squared. Notice how I always put that GCF in front. That's one of the factors, which tells me the answer is this, but we can still go ahead and do the work. Sometimes, you have to work smarter, not harder. But we'll go ahead and work it out. So this is 2 on top, 3 on the bottom. What numbers multiply to make 2? Well, there's only 2 of them, and they also add to make 3. So this factors into 2 times x plus 1 times x plus 2. And there it is. That's the one we circled. Last problem. What are the solutions? Once again, pull out that GCF. Same thing over and over again. X squared minus x minus 6 equals 0. And at this point, I need to factor. So I'm going to put a negative 6 on the top. Same numbers over and over and over again. We did that on purpose, all right? Numbers that multiply to make 6 and add to make a negative 1, a negative 6 and a negative 1. This time my 3 needs to be negative. So it's going to be 2 times x plus 2 times x minus 3 equals 0. Set each factor equal to 0. X plus 2 equals 0. Or x minus 3 equals 0. And subtract 2 from both sides. X equals negative 2. Add 3 to both sides. And x equals 3. Let's say negative 2, positive 3. There you are. So that's it, ladies and gentlemen. That's the test worked out completely. Watch it over and over again until you've got it. So